This is the On All Cylinders podcast,
powered by Summit Racing.
Your host for today is Summit Racing's Paul Sokolis, with special guests Bill Cummings and Dan DeKruger from LEED Brakes.
Here we go.
Hey there, it's Paul Sokolis in the host seat for today's installment of the On All Cylinders podcast. And one of the neat things about working at On All Cylinders behind the scenes is that you get insight into the data, which means you can see what stories are popular, what articles are getting shared via social media, and what comments those are getting. And if you take a step back and look at a macro level, you can kind of notice trends. And one of the trends we have discovered is that there are a lot of questions and comments and concerns about brake systems. Everything from the proper booster size to, does it make sense to convert from drums to disc and so on. So we decided to devote another episode entirely to brake tech. And to do that, we called up our pals at LEED Brakes, Bill Cummings, Vice President, and Dan DeKruger, Research and Development Manager. And these two folks know an awful lot about brakes, far more than I ever will. So with that, thank you for joining us on the show, gentlemen.
Thank you. Thanks for having us. Glad to be here.
Well, we're just happy to have you on because brake tech really is a complex, nuanced topic, and it really takes an expert to explain it to us neophytes out here. But before we dive into all that, we want to hear your backstories, guys. What got you into the gearhead culture, and what ultimately led you to your respective positions within LEED Brakes?
It goes back many years. Like every other car guy, started off as a kid, wrenching on cars, whatever dad had laying around, whatever junk cars he rolled into the lawn that my mother was mad at him about. We just started wrenching on them back then, and got into C10s, motorcycles, building some cars along the way. I've been in the brake industry since '97, specific to classic cars, and specific with LEED Brakes. I got in around 2014. Throughout my career, started in the warehouse and moved my way up through the ranks, all the way through to running VP of LEED Brakes.
How about you, Dan? Does any of that sound familiar?
Real similar backstory. My dad was a car guy. The town I grew up in, it seemed like everybody's dad was. So there was always cars in the garage. I was always interested in it. As soon as I could afford to start buying my own stuff in college, I had project cars and got into working in a parts store while I was going to school. And then after graduation, started working in the aftermarket side of things. Started in, phone sales, customer service. Kind of moved towards tech support because I had that hands-on experience, and ultimately that led me down the road of R&D, quality assurance, and getting into even the manufacturing side of it. In fact, Bill and I have worked together for over 20 years, so real similar path to get here, I guess.
So the moment we've all been waiting for, you guys ready to talk brakes?
Sure, absolutely.
Okay, so we kind of alluded to it at the beginning of this episode, but we have access to a lot of data here. We know what our phone tech lines are ringing with, we know what stories are trending, and we know what comments we're getting on specific topics in social media. And you two do as well, through your own tech lines and your own customer interactions. So we kind of work together to compile a bulleted list of some of the hot brake topics out there. And we'll run down that list as the episode continues. But we'll start with the big one because there seems to be some confusion about the distinctions between a specific brake component, or components, if you will. So can you take a moment or two and talk about the distinctions between a distribution block, a combination valve, a proportioning valve, what they do and where you'll find them in a brake system?
Yeah, that is definitely a misunderstood component on the car. There's kind of an assumption that anytime a customer sees a brass block with lines going in and out of it, that's a proportioning valve. And depending on the year of the car and what brakes were originally on it, a lot of times it's not. If it's a four-wheel drum brake car, it's probably just a distribution block, which is really just a manifold. It's just a point of splitting lines from 2 lines in to 4 lines out. They may have a brake warning light switch in it, but it doesn't do any actual proportioning. You get into the later cars that had front disc, rear drum. Those typically have an actual combination valve that includes proportioning, and that's going to obviously have a different function than that early one. So we see a lot of confusion when customers go from a four-wheel drum car to swapping to front disc brakes, or a front disc rear drum car, and then they go to a four-wheel disc brake conversion. They don't necessarily understand what they have versus what they need. Obviously when you've got a dissimilar braking system, so a disc in the front, drum in the rear, that's when you need that proportioning valve. The rear drums will lock up if they receive as much pressure as the front disc brakes, just because of the way that they function. So that's where it's important to have that pressure reduction to the back of the car. When you start talking about a four-wheel drum car and even a four-wheel disc car, a lot of times you don't need proportioning because you've got similar brakes front and rear. So if they're sized correctly, and if the tire and wheel combination and things are sized correctly, the car can run pretty much equal pressure front and back, and you won't get that severe lockup in the rear brakes. So that's where it's important to understand what you got and what you're converting to and what you're going to need is an upgrade from what's on the car now. That proportioning valve, just like we said, it decreases pressure. So you're probably going to get about 60% of pressure to the back of the car that you are to the front. If you're talking about a combination valve, like we said, that would include a metering function, which holds off the front brakes for a few PSI until the back brakes start to engage. That was typically seen on factory front disc rear drum cars. And then also that combination valve is going to include the brake warning light switch or the differential switch. And that's going to trigger your light on the dash if you have a brake line failure. And it's also, if it's functioning correctly, going to close off the half of the system that has that leak. That's going to help you maintain some pedal feel even after you have a line potentially blow out in the system.
So this sounds like a specific question that's going to arise big time when folks are mulling over a drum to disc conversion. Does that sound about right?
Absolutely. We don't necessarily understand what's on the car to begin with. They don't necessarily understand what they need for what they're changing on the car. And we do run into a lot of stuck valve situations where someone's got an original valve and it hasn't been tripped in 30 years and they just tripped it bleeding the brakes and now they can't get it recentered. Things like that are very common customer calls.
So what's the fix then? Is this a situation where you kind of just pull the old one out and replace it with a new one? Or is there any bit of maintenance or upgrading you can do to the current one to make it play nice with your new system?
Generally, it's really hard to find any parts for the original ones. We do carry replacements for the common GM valves that are out there. Sometimes you can actually remove the electrical switch that trips the light on the dash, and you can manually recenter that piston with like a pick or a scribe. But sometimes if there's enough rust, corrosion, residue, old brake fluid in there, it's going to just get stuck in place and you'll have to replace it.
Now, what advice do you have for someone who is mulling over a disc brake conversion, be it, just converting front drums to front disc or going all the way and doing four-wheel discs from their old 60s era, all drum equipped muscle car, cruiser, what have you? Should they have to seek out a specific valve that works for their system? Or, like, for instance, does LEED brakes spec out one that'll work perfectly and include it in, like, the disc brake kit?
So if you're purchasing a front disc brake conversion from us, we're going to supply you with a proportioning valve. Some of the kits we tend to use adjustable valves in because they're very simple to just tee in line, and you don't have to replumb the entire system to put that in. Some of the cars, I'll use GM muscle cars like your Camaro, Chevelle crowd. They like the factory style brass valve that looks like what would have come on the car if it was a factory disc brake car. So some of the customers prefer that. It's really not a one size fits all answer. It kind of depends on what you're going to do with the car. A lot of times I'll steer someone towards an adjustable valve. Say they're putting a front disc brake kit on this year, but they think they want to go to rear disc next year or year two. If we put an adjustable valve on the car for them, they can just readjust it when they make that rear disc conversion. They don't have to take a valve off. They don't have to replumb or anything. It's a simple upgrade for them at that point.
Yeah, and many of our front disc brake kits that we put together specifically for Ford and Mopar, we provide the adjustable proportion valve and the brake lines to connect to their factory distribution block. So they can just add that rear proportioning valve with the lines that we provide. And, like Dan said, if they want to upgrade down the road, all they have to do is adjust that proportioning valve and they don't have to touch anything on the front of the vehicle.
Okay, you've mentioned the word adjustability a few times already, so let's talk about that for a moment. Is adjusting the brakes like that something that the customer can do themselves, or is that something you recommend they take to a shop to have that work done?
No, something you can do in your driveway. So typically what we tell people to do is start with the valve in the middle. So you're getting good amount of line pressure to the rear drums or rear disc. drive the vehicle for 200 miles, a seat in the pads, just normal driving, no crazy stops, and get everything squared up to prevent any glazing. Then after that 200 miles, they can, in a safe area, do some heavier stops to see how the rear brakes react. And if they are locking up on them, they can reduce that pressure a little bit. If they feel they could get a little bit more out of the back, they can increase that pressure a little bit. And we often get the, where should I put this valve? It really depends on the vehicle, as far as where they set the pressure on that valve. Whether your tires will make a difference in what kind of rear line pressure you need, the way the suspension's set up, the way the engine's set up, the weight of the vehicle. So there's too many variables for us to say, well, you should be at 900 psi for the setup on this vehicle. It really is a seat of the pants feel.
That's absolutely correct. And the whole key with that proportioning valve is you set the rear pressure so the rear brakes don't lock up well before the fronts.
Yep.
If they do, obviously you have to let off the brakes to keep control of the car. Then you're not getting the most efficiency out of the brake system. So the whole idea is to get those rear brakes to reach that point of lockup around the same time as the front. So you have full use of the brakes and as much control over the car as possible.
You mentioned a while back something about an integrated switch into the block. And I think you said it controlled the brake pressure warning light. But from what I understand, there might be some other nuances that's worth covering. So can you talk about that for just a moment before we move on?
The combination blocks that are out there, including ours, there's a switch that's built into that, and the switch on the distribution blocks. People get confused between the two types of switches, and a lot of them think that the brass block switch is to activate taillights when it's actually just a brake warning light switch.
Yeah, we do run into that a lot with people that are doing, a drum to disc conversion on an earlier car that had, a single bull master cylinder, one line, may have had a hydraulic brake light switch to begin with. They think if they use that GM style valve, that they can use that to, again, actuate the taillights. And that's definitely not what it's built for. We do offer an adjustable valve that has that kind of switch, but the factory style brass valve is not meant for that.
All right, so let's move on to what is perhaps the second most common brake question. And this topic kind of revolves around a single part. And I'm talking about the master cylinder. On the surface, it looks like a relatively simple part, but there is a lot of science behind it. So let's just dive in. Let's talk about things like pedal ratio and bore size. And later we'll move on to like power brakes and vacuum assist boosters as well. But let's talk about master cylinders.
Yeah, absolutely. We have a saying here, it's never the master cylinder, because we get calls on whether it's a hard pedal, soft pedal, spongy pedal. With these cars, there's a lot going on with what front brakes are on it, what rear brakes are on it, how much engine vacuum the vehicle has if it's got power brakes, and master cylinder bore sizes. When we look at what's going on with the vehicle, somebody calls with a spongy pedal. Typically, the first thing that we have them do, we ask if they've bench bled the master cylinder off the vehicle. With our power brake systems, we actually put a card between the booster and the master cylinder that says removed before flight. The master cylinder has to come off to be bench bled. You can't bench bleed it on the vehicle. So we walk them through that process and those steps and how to properly bleed the master cylinder. If we're satisfied on that side, a lot of times if they have rubber hoses on the vehicle, we'll ask them to pinch off the 3 rubber flex hoses and isolate the master cylinder and depress the brake pedal. If they get a rock solid pedal after that, then we know the master cylinder is good and we can move on to the rest of the brake system and find out if it's caliper size, a bad rubber hose, a leaky wheel cylinder, something going on that can be causing that spongy pedal, or just the incorrect bore size for the brakes that are on the vehicle.
Yeah, the only thing I'll add to that bench bleeding is a lot of customers don't understand why it's necessary to bench bleed it off the car. They kind of feel like we're just making them do some extra work. What will end up happening, depending on your power brake booster, if it's a power brake car, your push rod assembly, how many layers of carpet and floor mats are on the floor of the car, you don't necessarily bottom the stroke out in the master cylinder by stepping on the brake pedal. So if you were to bleed it on the firewall or on the power brake booster, you might not get that last quarter inch, half inch of travel out of the master cylinder, and that's where the air will hide. Whereas when you take it off the car, you put it in a vise, you use a screwdriver to push that piston in, you can physically bottom it out, you can feel that it's bottomed out. And that's why off the car is important. It's definitely not us just looking to give you some extra work to do.
I'm glad you brought up the topic of bench bleeding a master cylinder because I know for a fact the Summit Racing tech lines get that question a lot, and that really is the best way to do it. Now, in a similar vein, I wanted to get your thoughts on gravity bleeding. That's where all you do is top off the master cylinder and keep an eye on it, and then crack open the bleeder screws on the calipers and wheel cylinders, what have you, and let gravity do its thing and let the whole system kind of bleed out naturally. Some folks say it works great. Some folks say it doesn't work at all. What are your thoughts?
Well, gravity bleeding is okay to bleed the calipers and the lines out. It's definitely not a fast process, but we actually have a lot of customers bleed brakes that way just because it's a very foolproof process. You don't need two people. You don't have the rubber hose going into the jar of brake fluid that pops off when you step on the pedal. It doesn't open up too many possibilities for mistakes. That being said, if you were to try and gravity bleed just the master, there's a lot of places in that master cylinder for hair to hide. And trying to just gravity bleed it will take an extremely long time. So we don't recommend that. But we do think it's fine for bleeding calipers.
And with the bleeding process, the way that we recommend to do it is to bleed the furthest reservoir first, because you're going to stroke that piston as far in as it can go, get all the air out of that reservoir first, and then do much shorter strokes to get the air out of the closest reservoir. So don't try doing both at once. Separate it and do the furthest one first, and that's the most successful way to get all the air out.
And be patient.
And be patient, yes. Oftentimes, we'll get calls, I've been doing this for 10 minutes, it should be done by now. Sometimes it's not, sometimes that air just gets trapped in a certain spot and it's tougher to get out.
Let's get into another subtopic of master cylinders here now. Bore size. Can you talk about the relationship between like bore size and caliper size? And what, in regard to bore size, should someone consider when modifying their brake system?
Well, I mean, generally, the larger the caliper, the larger bore you're going to need. But what's confusing, and I think the best way I can describe this is to compare it to an engine and a carburetor. You could have two V8 engines, one's 300 cubic inches and one's 700 cubic inches. They're going to need two different size carburetors. So just because you have a 4-piston caliper or 1-piston caliper or a 2-piston caliper doesn't automatically determine your bore size. It's determined by the piston size within that caliper. So that's something that I think a lot of guys miss. Well, it's a 4-piston, so I automatically need whatever bore size. But that's not the case. Depends on how big the pistons in that 4-piston caliper are. I think for most car guys, they understand the carburetor cubic inch kind of comparison. That's a good way to think of your brakes. It's the hydraulic surface area, total hydraulic surface area of all those pistons on the car that determines how big a bore size you're going to need.
Earlier, you mentioned some diagnostic procedures. Say a customer calls in with some concerns about their master cylinder. You give them some troubleshooting tips to kind of rule out the master cylinder and perhaps find an alternative culprit, if you will. Any other tips you can share with us?
Yeah, I mean, well, if they have braided hoses on the vehicle, they obviously can't pinch off those flex lines. So putting plugs in the ports of the master cylinder is very helpful. The one thing that we do run into all the time, the center rear flex hose is often the forgotten hose. A lot of people think it's just a vent hose back there or it doesn't exist, but that's always the oldest part of the vehicle. And usually once you start adding new pressure to it or higher pressure to it, it can start expanding and cause a spongy pedal feel. So don't forget about that center rear flex hose.
The other diagnostic thing that we do send people to get or use in a lot of cases is a brake pressure gauge.
Yep.
So, a lot of brakes is subjective. It's feel. The pedal feels too hard. The pedal feels too soft. I feel like the car's not stopping the way it should. We know what pressures we expect to see from a power disc brake system, a manual disc brake system, a manual drum brake system. So, we offer, and other companies as well, hydraulic brake pressure gauges. So you can screw them into the bleeder screw at the caliper, screw them into the bleeder screw at the wheel cylinder, and with a couple of adapters, you can even screw them right into the master cylinder ports. And we can use that as a diagnostic tool as well. When it's really, if it really gets to be a unique combination, a lot of parts that were never meant to be in the same place, sometimes that's the best way to really get to the bottom of it.
Yeah, and a lot of times we'll find that their pressures are good, and it could be something mechanical going on with the type of brake pads that are being run. If it's a ceramic pad or something that's a little bit less aggressive, it can give you a harder pedal feel and almost feel like the car wants to keep going as you're trying to stop. So it really could be just something as simple as changing out the pad compounds.
Just moving down our list of some of the common questions I know we get on the Summit Racing Tech line. Say a customer installs a brand new brake system, be it just a front disc brake conversion or a full disc brake swap at all four corners. We're talking new lines, new calipers, new master cylinder, the whole shebang. They get fluid in it, bled, and lo and behold, it's leaking. They got some leaks. And from what I understand, this is somewhat of a common occurrence. So if you ever get that call, what do you tell the person on the other end of the line?
Well, the first thing we're usually going to do is ask what brake fluid the customer's running. And that may seem like a weird question, but if someone's running .5 silicone fluid, and it's with a master cylinder or caliper that doesn't necessarily have the correct seals in it to work with silicone fluid, that will be a red flag right from the beginning. So we'll usually establish that right from the beginning. What fluid are you running and what components are there? Where did they come from? Different seals are manufactured under different processes. If they're not the correct type of seal for silicone, that's either going to be leaking or soon to be leaking. So we try and cut that off right at the beginning. And then like any other leak on a car, you can have something that's running down a frame rail, running down a hose. Where you see it on the ground can be far away from the point where it actually is coming from. So if it appears that it's a caliper leaking, we're going to have them check where the banjo bolt connects to the caliper, where the crush washers are. We're going to have them check the connections on the hoses where the crimps are. We're going to have you, look at the bleeder screw, wipe everything dry, spray it off with brake clean. Do you see evidence of fluid coming out around the threads on that bleeder screw? Is it not sealing correctly? So it's much like chasing any other leak on a car. It does usually take a little detective work, but like I said, the fluid type is going to be our first question.
It just wouldn't be a conversation on brake tech without a quick primer on leak diagnostics 101. We've covered master cylinders, we've covered proportioning valves and things like that. But I know we get a lot of questions about power brakes and power assist as well. So let's talk brake boosters. In particular, can you kind of explain the relationship between booster size and how it affects the brake performance?
Sure. I mean, the long and short of it is this is one of those cases where bigger is better. So the larger the booster canister, the larger the rubber diaphragm inside it is, and the more surface area there is for the vacuum to build that assist against. So a small booster is going to have a small diaphragm. That vacuum is drawing against a relatively small diameter surface. It can only provide a limited amount of assist. Bigger booster, bigger diaphragm, sometimes a dual diaphragm booster. So there's just more surface area for that vacuum to work against. So the bigger booster is going to give you more potential assist.
Okay, I'm going to ask a very specific question, and it's one that we've pulled right out of our customer service tech lines. Customer gets a brand new vacuum assist power brake system, installs it, bleeds it, hops in the car, starts the engine, and the pedal immediately goes to the floor when the vacuum kicks in. Can you explain this issue? Like, is it a problem with the booster or too much, too little vacuum? Walk us through the troubleshooting and how to prevent it from happening in the first place.
It's absolutely not a bad booster, but we get that call a lot because customers will install a system, they'll bleed the brakes, they'll pump the pedal up, all this without the car running. They'll get what they think is a pretty good pedal, so they'll think they're done, and they'll start the car. And once that vacuum is applied to the booster, now that pedal is extremely spongy. And it's not that the booster is doing anything wrong, it's that there was something wrong before you started the car. You didn't have all the air out, you had some mismatched parts, whatever the case may be as we work through the diagnostics with them. But they think that, oh, my pedal went to the floor when I started the car, this booster must be bad. And in reality, that's the sign that the booster is doing exactly what it should be, and there's something else in the system we need to look at.
And in that situation, from what I'm guessing, you'd ask the customer to go back and kind of double check their work, dot their I's, cross their T's, and perhaps even re-bleed the entire system?
Yeah, I mean, we would ask them exactly what they've put on the car. And if it sounds like it is the correct components, or if they purchased a whole system from us and we know what they have, then we're going to say, yeah, this sounds like an error situation. Did you bench bleed the master cylinder? Was it in fact off the car? If it wasn't, you're going to need to pull it off and re-bench bleed it. How have you bled the rest of the system? That sort of thing. But 9 times out of 10, that scenario is we haven't got all the air out yet.
All right, I'm gonna go back into our conversation about master cylinders because I've got sort of an anecdotal question here. Years ago, when I was first starting out, I accidentally ordered the wrong master cylinder for my early 70s Corvette. I have manual brakes, but the master cylinder I ordered was for power brakes. And unbeknownst to me at the time, that was a completely different part altogether with a different bore size. So can you kind of explain the distinction between a master cylinder for power brakes versus a master cylinder for manual brakes?
Yeah, and some cases it depends on the manufacturer. So everybody does things a little bit different. Now, your Corvette scenario, when General Motors went from manual brakes to power brakes, they also changed the brake pedal ratio. That's why you'll see, like on a Camaro or a Chevelle, the booster kind of points up at an angle towards the hood, and the master kind of points up. That's to hook up to a lower point on the brake pedal. So because of that change in ratio and all the assist that's being added with the booster, if you were to stick to the same bore size from manual brakes, the pedal would be really spongy. So they go to a bigger bore size, it maintains a good pedal feel, but you still obviously have the assist of the power brake booster, and your brakes seem easier to operate as far as how hard you have to push on the pedal with your foot. That's a real common issue we run into with customers too, because I'll use street rods as an example. I'm building a 1930s, 40s, 50s, whatever. I've got disc brakes off the front of let's say it's a Mustang 2, and it's got G-body calipers on it, and it's got a 9-inch with rear drum, and it has a tiny, tiny power booster because it's the only thing that would fit under the floor. And it has very low engine vacuum because it's got a fairly radical cam in it. And they go out and buy that 1.125" bore master cylinder because when we were talking about the Corvette or the Camaro, that's what came with power brakes. But unfortunately, they've changed so many other things about that system that's now not the right master for them, bore size, even though they have power brakes. So, I mean, the moral of the story is just because that bore size worked for power brakes on a factory application doesn't mean it's the right bore size for your aftermarket power brake application. And we run into that a lot.
You just touched on a topic I wanted to get to anyway, and now's as good a time as any. Summit Racing's got a lot of customers that are big fans of the aggressive cam. And as we all know, when you add a lot of overlap at idle, it has a tendency to kill engine vacuum, which of course has a detrimental effect on your brake booster performance. So what solutions or recommendations do you have for folks running that hot cam that may not be generating enough vacuum at idle to support a power brake assist?
Yeah, so it's going to depend. If it's somebody that already had power brakes and they put that new radical camshaft in and they feel like they've completely lost their power brakes. And essentially any of the boosters, regardless of their diameter, regardless of master cylinder bore size, you're going to need 15 inches minimum engine vacuum for the booster to really function correctly. So as soon as you put that high overlap cam in it and your vacuum drops down to 10 or 12 inches, the idle sounds great. But the vacuum is gone, and that booster will just never operate efficiently. You have little or no vacuum to make the power brakes work at that point. So there's some options. If you're close, sometimes a change in bore size can help you get back to where you need to be. But the solution we give to most of our customers in that situation is an electric vacuum pump. We have our own that we sell, a couple different styles of it. And that's going to give you, 18 to 22 inches of vacuum all the time, regardless of what camshaft you've got in the car. And then you can keep your power brakes. And in similar scenario, if you've already got that camshaft and you're converting to disc brakes or you want to add power brakes, that electric vacuum pump is, again, usually the best solution for those situations.
Since we are on the topic of engine vacuum, I've got a follow-up question, and this is an interesting one because you brought it up in sort of our pre-interview conversations, and I'm really curious about the answer. Does altitude affect engine vacuum? Or to ask that question another way, is power brake performance different whether you live in Denver or below sea level?
Absolutely. Absolutely. So I don't have the chart in front of me, but every 500 feet or so you go up has a pretty dramatic effect on your manifold vacuum. If you've got a fairly stock engine that made 18 or 20 inches at sea level, you may not really notice it at altitude. But again, if you've got that radical camshaft, or even if you're just on the borderline at sea level, you will notice a dramatic difference at altitude, and your brakes will get harder. We've seen some unique solutions to cars that are built in high altitude locations where people have changed brake pedal ratios and put smaller bore size masters on to kind of cover up those problems. And sometimes it's the second or third owner that doesn't even know what's been done previously to it. And even with the electric vacuum pump, just because of the air density at that altitude, it is less efficient at altitude as well. So there's a cutoff. If you get much above like 4,000 feet, it starts to become really complicated to solve those manifold vacuum problems.
Man, I would have never guessed. I do not envy your tech line folks.
Yeah, usually if somebody calls and they're having trouble breathing and have a hard pedal, we know where they're calling from and what the problem may be.
Let's bring up a topic that we've kind of touched on a little bit already, and that is pedal ratio. Can you describe the relationship between pedal ratio and brake performance?
I mean, it's basically like having a longer breaker bar when you're trying to break a lug nut loose, right? If you've got a really short ratchet, it's almost impossible. And if you've got the 3-foot breaker bar, it feels very easy. So the more mechanical advantage, the more brake pedal ratio you have, the easier it is to push the master cylinder, push that pedal down. But like everything else in the brake system, it has to match what else is going on with the car. So if you have a really high pedal ratio, but you have power brakes, the brakes will become very, very sensitive. It's the scenario of, I touch the pedal and I feel like I'm going to put myself through the windshield. So it all has to match. The pedal ratio, the bore size, and the booster that's on the car kind of all have to work together. So that's sometimes where you can use one or the other to help tune a system a little bit, but they all have to make sense together.
So I'm guessing now would be a good time to ask this question then. I'm assuming LEED Brakes offers like a portfolio of products that can be selected and pieced together individually to fine tune and support a customer's specific brake needs.
We do offer a bunch of different push rod combinations. So sometimes it's a situation where you can go from a straight push rod to like a pistol grip style push rod, drill an additional hole in the brake pedal. We have some bolt-in pedal pins that we offer. So you don't necessarily have to weld a pin on like some of the factory pedals. If we're talking about a lot of the General Motors applications, your Camaro, Chevelle, Corvette, they had multiple holes drilled in the pedal right from GM because they were building those cars both ways. So if you didn't have the factory power option, you were in the higher hole in the pedal. And if you had the factory power option, you were in the lower hole in the pedal. Mustangs, for example, much more complicated. We actually manufacture correct power pedals from 67 through 70. Ford actually installed different pedals in the car depending on if it was power or manual. So we reproduce that pedal for our conversion kits.
And some people use the same pedal from the manufacturing side, Mopar, for instance, even some of the Ford applications, and they put a Z-bar style mechanism on the back of the booster to reduce the manual brake pedal ratio to power brakes. So there's a lot of ways to skin the cat. The most effective way is with a straight push rod, but the Z-bar is pretty effective. It just pushes the booster further away from the firewall.
I always found that interesting, the different engineering philosophies between the automakers, like Ford making an entirely different pedal versus GM just drilling holes in the same pedal to accommodate different setups. But I digress. Let's get back to some of our tech questions. We get this one a lot, and I'm imagining you do as well. Say someone does a rear disc brake conversion on their 60s era muscle car, cruiser, what have you. They get the system installed and bled, and they're still fighting a spongy pedal feel. What troubleshooting steps do you recommend in that situation?
Yep, absolutely. Yeah, we get that call a lot, and it could be several factors. Kits like our rear disc brake kits that have the built-in parking brake, there's a specific way to set up those calipers when you install them. If you just put them on the vehicle, hook up the hydraulic hose to them, and pump them up hydraulically, the parking brake piston does not come out with it. So that creates a spongy pedal. In our instructions, we give a specific way of how to set up that caliper. So you put the caliper on, basically work the parking brake lever several times until the piston meets until the brake pad meets the rotor. And then you can only move that lever about a half an inch. Then you can put up the hydraulic hose up to it and bleed the brakes, and that'll give you the firm pedal. So if we get the spongy pedal call and we know what kind of calipers in the rear disc brake kit that they've added, that's the first thing we walk them through is how to properly set up that caliper. And there's a lot of videos out there. There's a lot of information out there on different ways to do that caliper. And it's actually a lot simpler than what's out there. If you've already put the caliper on, pumped it up hydraulically, you just take the caliper off, turn the piston all the way back into the factory setting, reinstall the caliper, work the parking brake lever, until the piston comes out, and that should resolve the problem 99% of the time, unless it's a master cylinder bore size issue. That resolves the issue right there.
We feel very strongly that the way we adjust those rear calipers is the safest and simplest way to do it. There's a lot of videos where guys are taking the levers off and they're turning screws and taking pistons in and out, and then they damage seals. And
Yep.
The way that Bill's saying to approach it is definitely the simplest and most effective way to do it.
And if folks wanted to check out some of this tech information or these tech videos, do you have that available on your website?
Yeah, so we have very general tech information on our website right now. We're actually building a library, and we're going to have some videos soon on various topics that we've covered today to go over how to, bench bleed a master cylinder, how to adjust a caliper. LEEDbrakes.com.
Okay, continuing along sort of our tech question path here, we run into this situation a lot. A customer will call in about a spongy pedal feel, and when we recommend that they rebleed the system, they come back and say, well, we bled and rebled. We should be good to go. We got fluid coming out of the calipers, but we still got this spongy pedal. What can we do? Do you ever bump into that? And if so, what's your cause and solution there?
We run into it a lot. Some of the aftermarket calipers that are out there have 4 bleeders in them. So top, bottom, inner, and outer. Sometimes people just like to open the one they find most convenient, which is usually the bottom one. And we also see it even with factory style calipers where people will put the left on the right on the left, and the bleeder screw is now pointing down. And for people that aren't really experienced with brakes, that doesn't even throw a red flag to most of them. Hey, caliper's on, everything bolted up, the line's connected. I opened the bleeder, the fluid came running out. It must be good. So we run into it quite a bit. And it's just a matter of, that bleeder's always got to be a high point. And that's the only way you're going to get the air out of the system.
And a lot of times we'll get customers that call, they've got a vehicle in, they've been trying to diagnose it for a while, and it's not something that they installed. They're working on something that somebody's already installed and they couldn't get it fixed themselves. And we'll go through the regular scenarios of, pinching off lines and whatnot, and ask what seems like an obvious question: how about the bleeders on the front calipers? Are they pointing up or pointing down? And they go, oh my God, can't believe I never saw that.
Full disclosure, arm raised. I've been there, done that. Now, we're about ready to wrap up, but since we've been talking about some specific issues, I want to close with some more broad questions that'll hopefully help folks who are considering a disc brake conversion or upgrading the brakes on their classic car. And the first being a simple one. What, in your opinion, is the most overlooked aspect of a disc brake conversion?
Wheel size.
Yep.
So there are solutions for 14-inch wheels for sure. We offer quite a few kits that will fit 14-inch wheels. Like anything else in the world of wheels, we can't guarantee every 14-inch wheel ever made from every manufacturer. But rear disc is a challenge with small wheels. So we typically start at 15-inch wheels with rear disc stuff. But definitely the size and style of the wheel and how that will work with a disc brake conversion is, I think, where a lot of them customers need to start or need to consider. And I would much rather tell a guy who's getting ready to buy wheels and brakes what size he needs than to tell someone who already bought wheels why they're not going to work with the disc brakes that they now want to buy. So, and
you're just talking about the sheer simplicity of fitting the physical caliper inside the wheel, right?
Yep. Yeah. And it's really, we have to have the conversation by wheel size, but it really comes down to the way that wheel is shaped and styled. Some of the factory wheels, regardless of whether they're 14x6 or 14x7, just were never designed to clear a disc brake caliper. And vice versa, there's some wheels out there that are pretty small that will clear. And those are the things we've learned through the years of doing this. But everybody needs to remember that if they've got wheels on a car that never had a disc brake option, those wheels weren't built with disc brakes in mind. So they may pose a problem.
Now, again, since we brought up rear disc brake conversions, what does that mean for the parking brake? Does a rear disc conversion accommodate a parking brake?
So all of our rear kits include a parking brake mechanism. So it's built into the caliper. The lever is on the back of the caliper. That's where your cable is going to connect to. And that is mechanically pushing the piston and the caliper out when you pull that lever and pull that cable. So everything we do has that function built into it.
Now, we touched very briefly on the topic of brake fluid. So I'll ask a pretty basic question here. What brake fluid do you recommend to someone who's installing a brand new, doesn't have existing brake fluid already in it, a brand new disc brake system in their classic car?
Well, I mean, normally we're going to tell a customer to run with a .3 or .4 fluid. The silicone idea was great 20 years ago. All the components that were out there were manufactured with a seal that was silicone safe. And as time has gone by, it's become really difficult for us to be able to tell a customer that all the seals on their car are going to work with silicone. I can tell them whether a specific part they purchase from us will work with silicone or not, but I have no confidence level that their other parts of their system have got the right seals in them for silicone. So just to avoid the calamity, we pretty much steer everyone away from silicone at this point. And honestly, unless it's a museum piece, it's really not the best solution for performance anyways.
And I think you see that warning across most manufacturers' instructions now is that .5 silicone will void the warranty on any brake products.
Yeah, thanks for that, because you got to the bottom of the question I was kind of hoping you'd answer. I wanted to hear your thoughts on the silicone-based brake fluids, so that's really good information to have. My other question, and we've kind of talked about it earlier, but say someone is mulling a disc brake conversion on a vintage car, should they also consider upgrading or at least assessing the health of their current ancillary systems like chassis and suspension? What else should they think about before doing the job?
Sure. I mean, it's like any other change with the car. I mean, if I'm having a conversation with a customer who's not even sure what they want to do for brakes or tires or wheels, I always have the conversation of, what are you looking to do with the car? Is this a Sunday cruiser? I'm going to go get ice cream. Is this, I'm going to autocross it? I'm going to drive it across country. Like, what are the goals with the car? Ultimately, the only thing that touches the road is tires, right? So tire and wheel size and suspension will have a huge effect on braking. Just as much as you can't fit big brakes on a 14-inch wheel, you probably don't have enough tire with that 14-inch wheel to utilize those big brakes anyways. So I think it's about having a realistic conversation of, what's the budget? How are you going to use the car? What are your goals? Are you just looking to make it a little bit safer so you can feel comfortable when you're out driving with your family? Or are you really looking to do something that's very performance oriented and you have some specific goals with the car? But definitely, if you're stopping, weight is shifting forward. If you've got old worn out front springs and bushings and all that weight is sliding to the front of the car and you have small wheels and small tires, it's not going to stop well. If you've made the suspension upgrades, so the car isn't nosediving as much and you've got wider tires and bigger wheels on the car, then there's more that the brake's going to offer you.
And the one thing that LEED Brakes does with our all of our components or our kits, we offer them in a way that you can add on stuff later on without having to change everything at the front. So you can start off with a power brake booster and master cylinder combo for 4-wheel drum brakes. And we get the question all the time, if I add disc brakes down the road, do I have to change this whole setup? No, you can still use the power brake booster, just got to change to the master cylinder. And, we have a combination for that as well. So then they get the disc brake set up, they just get everything at the wheels, the new master cylinder, and then, hey, what happens with disc brakes in the rear down the road? With the adjustable valve, you can just add the rear disc and not have to change anything else up front.
Yeah, I mean, we get a lot of customers that will even keep their 4-wheel drum brakes, but they might want a dual bowl master cylinder for safety. They might want to add a power booster for a little bit better performance. Typically the muscle cars, the Camaros, the Mustangs, the Cudas, those guys drive those cars a little bit more aggressively. They want the disc brakes, and the drums were pretty small on a lot of those cars. The bigger cars, if we're talking about an Impala or a Chrysler 300 or something like that, it had big drums. You're probably not driving the car super aggressively. A lot of those guys are happy just to put a dual bowl master and a power brake booster on them. And we offer all those solutions for those cars.
And your answer kind of really dovetails into my last question, and that is, how does this process begin? It sounds to me, and please correct me if I'm wrong, that you want people to call you, right? Before they make a purchase, before they start bolting on parts, you want to have that conversation on their brake system as early as possible to ensure that they're steered, pun intended, in the right direction. And if that's the case, and I'm pretty sure it is, how do folks reach you? How do you recommend they contact you?
Yeah, so that's how we built our business, was being the tech guys to go to for brake solutions for your vehicle. And, whether it's an older car or a C10 truck, They can give us a call at our tech line, the 716-852-2139 number, or shoot us an email, tech@leadbrakes.com, and we'll walk them through what's on the vehicle, what's needed to repair the vehicle or upgrade the vehicle, and what to look for in the future for any upgrades or wheel size questions that they may have. Our guys here are all car guys. We're all built from the same mindset and love helping people and talking to people on the phones. And we don't have a timer on our phones. Hey, get off, get to the next guy. We enjoy talking to our customers, walking them through what they have going on their vehicles to make a safe solution for them. Because there's a lot out on the internet right now. There's a lot products that are out there right now. A lot of guys, even in the 60s and 70s, try to do disc brake kits themselves, and it may have been too small of a system for that vehicle originally. We run into a lot of Mustang 2 stuff for the old street rods, where boosters and masters may not be sized right, pedal ratios might not be right. So we really like to walk them through everything they have going on to make sure they get the right solution.
Yeah, I mean, we're definitely happy to help somebody diagnose a improperly spec'd out system and get them down the road safely. But I think we'd all agree we'd rather help them buy the right parts in the first place and put a safe, well-operating system on the car from the beginning. But we're happy to talk to them either way.
Yep.
So we're about ready to put the brakes. That's my second pun in the last couple minutes. Put the brakes on this interview. Is there anything you want to tell us about LEED brakes? Like, do you have anything cool and interesting up your sleeve that we should know about?
We're always expanding our product line, right? So we're coming out with new products all the time, and our new products are from the voices of our customers. So we listen to our customers, we listen to what they're looking for, and that's what drives what we put out in the marketplace. So call us with your requests, let us know what you're looking for, your stumbling blocks along the way, and we certainly pay attention to that. We've got many new products that we released this year and many more coming, and I think it's all stuff that customers are looking for in the market.
Yeah, and I think the only thing I would add is, as far as compared to other brake companies that are out there, we put a lot of effort into the boosters and the master cylinders and matching the correct hydraulic components with the calipers, even if they're not our calipers. So, we have a lot of customers that have got a brake kit from somebody else or brakes they took off of something from the junkyard or whatever, and we spend a lot of time helping them get the correct bore size, the correct booster, the correct pedal linkage, push rod. And I really think we do a much more thorough job at that than a lot of our competitors that are out there.
You want to shout out your website again to give folks a place to start that conversation?
LEEDbrakes.com.
And before we wrap this thing up, do you have any closing thoughts on brakes or brake systems?
Well, and I'm sure every manufacturer you talk to says the same thing, but I personally feel like it is one of the most misunderstood systems on the car. Most car people are really interested in making horsepower and really interested in making it look cooler, look better. But this is like one of those things that they think of later and don't really understand and don't usually put the homework into.
Yeah.
And probably the one thing they should put the most homework into if they're going to do it on their own. But
stopping is just as important as going, right?
That's it.
Well, I think that's an excellent sentiment to end on. We've been talking with the folks from LEED Brakes all about brake system tech, troubleshooting, and upgrading. It's been a good conversation, eye-opening. Learned a lot of new stuff, which is always a good thing. Gentlemen, thank you so much for the time, and we look forward to working with you more in the future.
Yeah, thank you. It was a great time.
This has been the On All Cylinders podcast.
Powered by Summit Racing.
Check out new episodes coming soon at OnAllCylinders.com.
OnAllCylinders.com.
Thanks for listening.
See you next time.